Hello everyone, my name's Dr. Vile and welcome to my A-Level Chemistry YouTube channel. The purpose of this channel is all about getting you ready for your A-Level Chemistry exams. And with that in mind, this video is going to focus on one of the AS practicals, which is where we determine an enthalpy change for combustion, so where you're burning a fuel in oxygen, and we're going to do this using a spirit burner. Now you can think of a spirit burner as effectively a special type of candle where you can burn fuel. If you find this video helpful, remember to like, subscribe and keep checking back for more content. So on your screen at the moment is the practical apparatus that you need for the experiment. You've got various aspects to it. The first thing you need is your spirit burner. And as I say, a spirit burner is basically a glorified candle. You fill it with the fuel that you're going to be burning. It's then got a wick and you light it just like a candle. You then have a gap, this gap here, between the spirit burner and the conical flask. This gap needs to be kept at a constant height every time you do the experiment. And then you've got your conical flask, which is shown here, and your conical flask is filled with a given volume of water, which is very important that it's measured out accurately. And when you do the experiment, there are several things that you need to know in order to do the calculation. So firstly, you need to know the type of fuel that is in your spirit burner. So it could be it's methanol, it could be it's ethanol, could be butanol, etc. So you need to know the type of fuel. Secondly, you need to know the mass of the spirit burner before igniting it. So the mass of the spirit burner before. And then you need to know the mass of the spirit burner after heating. Both of those are measured in grams. And what you'll find is that the mass of the spirit burner before is higher than the mass of the spirit burner after heating. It's lost mass because you've burned some of the fuel. And the difference between these two values will tell you the mass of the fuel that was burned. So you need to know that. You need to know the volume of the water. That's really important. And if you know the volume of the water, you effectively know the mass of the water. So we'd normally measure volume in milliliters. And then you also need to know the temperature change of the water. So the temperature change of the water, that would be in degrees Celsius. And once you've got all of that, we can start to do some investigations. So let's have a look at some example results and we'll talk you through it. So before we get into any actual examples, let's just remind ourselves of the formulae that you need to learn for this topic. The first equation is delta E equals M times C times delta T. So let's look at what each of those terms mean. Delta E means the change in energy, or the energy change. And it's measured in joules. M is the mass of the water that's being heated. So do you remember in the previous slide we looked at the flask, the conical flask that had a given volume of water. So if it was 100 mils, it would be 100 grams of water. So that's measured in grams. C is called the specific heat capacity of water. And it's a constant, it's on your data sheet, and it is 4.18 joules per gram per Kelvin. Now what that means is that if you take water and you have 1 gram of water, it will take 4.18 joules to heat that 1 gram of water by 1 Kelvin. So it's a constant but only for water. And then delta T is your temperature change. and that's measured in Kelvin. Now you might be thinking, hang on, we just measured our temperature change of the water with our thermometer in degrees Celsius. Well, if the temperature change goes up by 10, the temperature change in Kelvin would also be 10 as well. So when we're dealing about changes in temperature, it's very easy to convert between degrees Celsius and Kelvin. So this is our first formula that we need to know. The second formula is delta H equals minus delta E over N. So delta E is our energy change, but I would suggest that we convert from joules to kilojoules at this stage by dividing by 1,000. And the reason is delta H is our enthalpy change, and that is measured in kilojoules per mole. And N is the number of moles, which is normally measured by the mass of the fuel divided by the molecular mass of the fuel. So it depends which spirit you've got in your spirit burner. So if it was ethanol, you'd work out the molecular mass of the ethanol, and M is the mass loss of the ethanol. So if the spirit burner went down by 0.5 gram, that would be your mass of fuel there. So N is the number of moles of the fuel that were being burned. Okay, so let's look at some data here. We've got two fuels, methanol and ethanol. For methanol, the temperature of the water went from 19 degrees Celsius to 59 degrees Celsius. The mass of the spirit burner went from 135.34 grams to 133.67 grams. So we need to work out the enthalpy of combustion of the methanol. Firstly, let's draw out methanol. Methanol has one carbon, it's got an OH group, and therefore it must have 3 hydrogens bonded to the carbon. So this is methanol, and its formula is CH3OH. So its molecular mass would be 12 for the carbon plus 3.03 from these 3 hydrogens plus the 16 from the oxygen plus 1.01, and that comes out as 32.04. So that's the first stage. So let's write out the equation that we need. Delta E equals m dot c dot delta T. Well, M, you've got 100 centimeters cubed of water being heated. That equates to 100 grams. So you've got 100 grams. The specific heat capacity is 4.18. Just look it up on your data sheet. And the delta T, you've gone from 19 to 59. That is plus 40. And that comes out as 16,720 joules, which is 16.72 kilojoules. Secondly, then we need to work out the number of moles of the fuel that were being burned. So N equals M over MR. Well, the mass is going to be the difference between these two numbers here. So what this shows us is that 1.67 grams of the fuel were burned. We've already said that methanol has a molecular mass of 32.04. So if we put that in your calculator, we've used 0.0521 moles. And then lastly, we pull this all together and say that delta H equals minus delta E over N. So that's minus 16.72 divided by 0.0521 And that comes out as minus 321 kilojoules per mole. So it's exothermic, which makes sense because it's a combustion of a fuel. So minus 321 kilojoules per mole. Now I would strongly recommend pausing the video at this point and have a go at ethanol, and then unpause and see how you got on. So ethanol, we can draw it out, has 2 carbons, 1, 2, you've got an OH group, and then your hydrogen, so CH3 and CH2. So its molecular formula is C2H6O, and its molecular mass is therefore 46.06. So we'll need this information in a second. Now our formula is delta E equals M dot C dot delta T. So M is the mass of the water, it's 100 centimeters cubed, remember that's 100 grams. Density of water is 1, so it's 100 times 4.18 times delta T. Well, it's gone from 21 to 61, so that's once again a 40-degree rise. And same as before, that's 16,720 joules, which is 16.72 kilojoules. We then need to calculate the mass of the the moles of the ethanol. So we know that N equals M over MR. Now M is going to be the mass of ethanol, so that's going to be 148.39 minus 146.84. And that comes out as 1.55 grams, divided by the molecular mass, which is 46.06. And that comes out as 0.0337 moles. And then in our final calculation, we know that delta H equals minus delta E over N. So that's minus 16.72 divided by 0.0337. And that comes out as minus 496 kilojoules per mole. And you can see that's more exothermic. So when you go compared to methanol, so when you go from methanol to ethanol, it releases more energy per mole of the fuel. And if we were to carry on to propanol, it would release even more energy again. Well, anyway, thank you for taking the time to watch this video. I hope it was helpful in terms of how to calculate an enthalpy change when using a spirit burner. It's fairly straightforward to do. You just literally burn the fuel and use it to heat up the water, measure the temperature change of the water, the mass of the water, and the amount of fuel that was needed to do it. And you can quite accurately work out the enthalpy change of combustion. If you found the video helpful, remember to like it, subscribe, share with your friends, and keep checking back for more content. Thanks everyone, see you next time.